Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to talk about classifying triangles, both based on their angle measurements as well as their side length. So some of this vocab, again, you've been exposed to before in middle school geometry classes or another middle school class. But now we're going to dig a little deeper today, and we're going to eventually do some proofs as well as show you where a common theorem that you always studied actually comes from. So first thing you can do is work through the do now. There are 3 questions. So go ahead, pause the video, take a few minutes to work through that, and then we'll go over some answers. All right, so number 1 says, draw an example of an acute angle, show a degree measurement. Well, we know acute angles are greater than 0 but less than 90, so I'm going to go with 30. But of course, there are many answers that you could have here. Number 2 says, draw an example of an obtuse angle, show a degree measurement. I'm going to go with 107 degrees. Obtuse angles, we know, are greater than 90, less than 180. Number 3 says, actually there's 4 questions here, I just didn't label the 4th one. Draw an example of a right angle. No need to put a measurement there. If I put the box, if I wanted to put a measurement, I could put 90 degrees. Only need one of those. The box implies that the degree measurement is 90. And number 4, if the perimeter is 47, find x and the length of each side. Well, perimeter means that we need to add up all the lengths of the different sides. So 2x plus 6 plus x plus 3 plus 3x plus 8 is equal to 47. If I do some combining of like terms, I'm going to get 6x plus 17 is equal to 47. I'm going to get 6x is equal to 30. And I'm going to get x is equal to 5. Just make sure that you're not done yet, right? We've got to find the length of each side. You could do some substitution. I'm just going to put the answers here. 16 here. We get 23 here. And we get 8 here. And you could also go back and make sure that those 3 sides add up to 47. If they didn't, you would know you did something wrong in finding x. All right, let's jump into some vocab for today. So the first thing we're going to talk about is classifying triangles based on their angle measurements. So a triangle is a polygon with 3 sides and 3 angles. So again, a polygon just means a figure with many sides. A triangle is a specific type of polygon with 3 sides, 3 angles. 4 ways we can classify. We can say it's an acute triangle. This is where all 3 angles are less than 90 degrees, right? So maybe we have 60, 40, and 80, or 3 other angles that are all less than 90. Equiangular means that all 3 angles are the same. One theorem we're going to prove a little bit later in this lesson is that all 3 angles in a triangle have to add to 180 degrees. I think that's something you've done before, you've worked with, that all 3 angles need to add to 180. Later today we're going to talk about why that has to be true though. That being said, if all 3 angles are equal and they have to add to 180, well, they should all be 60 degrees, correct? Because 60 plus 60 plus 60 gives us 180. The right triangle, this is where we have 1 right angle. You could think about, well, why can't we have a triangle with 2 right angles? I'm not going to answer that right now, but that would be a question to think about, and think about if you could accurately explain why you can't have a triangle with 2 right angles to someone. An obtuse triangle is where we have 1 obtuse angle in the triangle. The other ones will be acute. Again, think about, well, why can't we have 2 obtuse angles in a triangle? Right? Why can only one of them be obtuse? But these are the 4 categories that we're going to be classifying triangles by based on their angle measurements. Let's now look at how we classify triangles based on sides. We have the equilateral triangle, 3 congruent sides, same prefix as equiangular for 3 congruent angles. Isosceles triangle, at least 2 congruent sides. Now sometimes you'll see the definition of isosceles as exactly 2 congruent sides. The one we're going to use here is at least 2 congruent sides. So notice that notice that all equilateral triangles are isosceles. Not all isosceles triangles are equilateral, though. Sometimes they may be, sometimes they won't be. And then a scalene triangle is where there are no congruent sides. So they may show this with tick marks of all different varieties on those three sides. All right, let's do some practice. We will just do, actually we'll do both these because one is based on angles, one is based on sides. It says classify each of the triangles in the diagram below by their angle measurements. You may have to find some missing angle measurements. So remember that theorem I talked to you about. All three angles of a triangle need to add to 180. We'll prove that later, but just understand that for now. Okay, let's start with EFH. And I just like to trace these. So EFH, that's that triangle right there. Well, we have a missing angle measurement. We need to find it. But if I know that two are 30, we'll just call this X. 30 plus X is equal to 180. 60 plus X is equal to 180. And X must be equal to 120. Well, if X is equal to 120, what category would that fall into? That would make it an obtuse triangle because one of the angles is greater than 90 and less than 180. There are other ways you could figure out that 120 degrees, right? We could have used the fact that the two angles here are linear pairs or a linear pair, right? So they should add to 180 as well. FHG. We'll do this one in blue. Oops, still on my eraser. Hate when I do that. Leave this one red, then we'll go to blue. FHG. We also have a missing angle measurement up there. Multiple ways we could find this, but that angle is 60 degrees. And you could think about what are the different ways you could figure out that that's 60. If all angles in the blue triangle are 60 degrees, though, that makes it an equiangular. It's a fun word to say, equiangular. All right, last one, EHG. We'll do that in, let's do that in lime green. EHG. So I have a 30-degree angle, I have a 60-degree angle, and up here we can see that this is a right angle. So this entire triangle is a right triangle. All right, on to number 2. We're classifying by sides. Let's do A, B, C in red. Well, we notice that there's 2 tick marks here. So if one side is 15, the other side is 15. But the bottom side is also 15. So essentially we could have 3 tick marks here, which means that this is an equilateral triangle. Equilateral triangle. Let's look at ABD. ABD. So I have a side that is 15. This bottom side combined, right, gives us 20, and the other side is 18. All those sides are different lengths, which makes this a scalene triangle. And then I have triangle ACD. I have side lengths of 5, 18, and 15, which makes this also a scalene triangle. All right, moving on. Again, I think it helps to outline those triangles if you have different colored pencils or pens or something, just to keep those straight when you're dealing with diagrams that have multiple triangles in them. We're going to skip number 3, and we are going to actually skip the proof as well. What I want to do is I want to go down here to the informal proof of the triangle angle sum theorem. So this is the theorem that I was talking about where, and you can read it right here, if we have a triangle ABC with angles A, B, and C, then the measurement of all those angles will be equal to 180 degrees every single time, regardless of what type of triangle you have. So what I'm going to do is I'm going to scroll down to the diagram below, and I will just read the different questions that we have going on. And we're going to walk through a proof of the triangle sum theorem. What I would encourage you to do before you listen to the proof and watch what's going on is to try this on your own. I kind of give you some hints along the way. We're not writing out a 2-column proof. We're just kind of going to have a diagram and we're going to talk through about the different pieces. But I would encourage you to try to work through this on your own and see if you can understand why these 3 angles have to add to 180 degrees. All right. Number 1 says, first draw an auxiliary line through point A that is parallel to BC. So it's got to go through point A, and it's got to be parallel to BC. I can show that it's parallel by putting arrows on both BC and that line up there. Number 2 says, can you fill in any of the newly created angles? Explain how you know what their measurements should be. Well, we don't have any measurements per se numbers-wise, but are there any, let's say, are there any other angles that we could label as B or A or C? Well, let's take a look at C first down here. If I extend these segments, which I'm allowed to do, if I just extend them, well, C and this angle up here are both on the inside of the parallel lines, right? If I look at my parallel lines in red, they're both on the inside, and they are opposite. They are on opposite sides of the transversal, which I'll just re-sketch in black. So if they're on opposite sides of the transversal and they're on the inside of the parallel lines, that makes them alternate interior, which means they are congruent. So this angle up here could also be labeled as C. The same thing applies with B, right? I just have a different transversal. My transversal this time, let's do blue. And that was my eraser. Transversal, still my eraser. There we go. I'm going to put the transversal in blue. Oops, I guess I still need my red. There we go. Now we'll do the transversal. Okay. So if I look at B and this angle up here, right, they're both inside the red parallel lines, which makes them interior, and they're on opposite sides of that blue transversal. So these are also alternate interior, which means they are congruent, which means I can label that one as B as well. If you didn't understand that explanation for alternate interior, I'd encourage you to pause the video and go back. Make sure you're sketching out your own diagram, trying to figure out what lines are parallel, etc., to figure out the relationship. Once I have that, though, right, well, what's going to be the relationship between B, A, and C? What do they all form? They're not a linear pair because there's more than 2 angles, but they all form a straight line together. So I could say the measurement of angle B plus the measurement of angle A plus the measurement of angle C is equal to 180 degrees because they all form together a straight line. So what that means is that it doesn't matter where those angles are, whether we're looking at the ones inside the triangle or whether we're looking at the ones on the line, they're all going to add up to 180. So given any triangle, all 3 interior angles will always sum to 180 degrees. And if I gave you any triangle, we could run through this process with it again. Either way, you could show that those 2 other angles are alternate interior, and you could match them up with the third angle to show that they all form a straight line, which means that they all three should add to 180. So maybe that's what you want to do. Maybe you want to take another angle, and let's actually just do that. Just to show you that I didn't just choose a special triangle that works. Let me just draw a random triangle on here. Ooh, maybe we'll do a right triangle, because that one up there was not right. Or at least it wasn't marked with any little boxes. So we'll call this angle A. We'll call this angle B. And we'll call this angle C. So think about our process. We can draw a line that is parallel to CB that goes through A. So this line right here, parallel to CB, and it goes through A. And you could actually choose any vertex that you want. I could have drawn that line parallel to AB and have it going through C. I could draw it parallel to AC and have it going through B. This method works with whatever vertex you choose. Now, let me extend these parallel lines. Keep forgetting I'm doing the same color. Just doing both in red again. Okay, so there's our two parallel lines. Let's look at C first. So here's my transversal. Right, well, we can see that this angle and this angle, they're both on the inside of the red parallel lines, and they're both on opposite sides of the transversal, so this angle could also be called C. I could now think about angle B. I'm going to erase this transversal so we're not confused. Draw another transversal. So here's my other one. So I'm looking at this angle and this one. They're both on the inside of the red parallel lines, and they are on opposite sides of that blue transversal, so this angle is also B. And notice that we have again shown that C... Oops. Every time, right? There we go. And on my pen. So again, we've shown that C, A, and B form a straight line, which means they're all going to add to 180 degrees again. So again, if you want to try this, maybe you want to try to draw a triangle that you don't think is going to work with this process. And you could try one and then try the process and see whether it works or not. But it will work for any triangle, which means that this theorem holds true. We can generalize this theorem to any type of triangle that we can think of. All three of the angles are always going to add to 180 degrees. So it's an important theorem. It's one that you've probably learned before, but hopefully now this provides you with some more insight because now you know why it works and where it comes from. All right, that's going to be the end of this video. As always, enjoy the rest of your day, and I look forward to seeing you next time.